Yes.
Good morning, grade 9, my advisory. Okay. This is a continuation of heat work and efficiency, our topic for the fourth quarter. Okay. First module, weeks 1 to 4, right? And this will be the basis. Okay. This topic will be the basis for your project. Okay. Project is different from your performance task, but it is one of your performance tasks. Okay. Talking about your project will be your output for this school year. Okay, I will give you ample time to do your project. Sir, what is this project all about? Okay, what will you do? What I want you to do is a concept. Okay, this is based on our lesson. We call this one as learning resource. Okay, a learning resource is anything that explains the concept. That's a learning resource. I will just put it on the in your LMS. This is not just a mere picture or a PowerPoint presentation or a video. It's a mere thing that explains the concept. Okay, it's a mere thing that actually expound the concept. Okay, that's a learning resource. Okay, I will explain it further. Okay, let's move now to four-stroke engine, just like the engine of your cars. Okay, when a mixture of air and fuel enters the cylinder to the intake valve, the cylinder compresses air-fuel mixture. The compression pushes the spark plug, which is actually located above your piston, which causes gas to ignite, producing heat. Okay. Once the piston hits the bottom, the exhaust valve opens. The burned air fuel mixture is expelled through the exhaust valve as piston returns back. Okay, so this is now your four-stroke engine. Okay, it is also again one of the example of heat engine because it produces heat actually. Okay, because of the compression that is happening inside the cylinder. Okay, the compression of air enables again the spark plug to spark, producing fire. Okay, and burning the what? The fuel and air mixture there. Okay, fuel and air mixture. Once it returns down, okay, the exhaust valve opens to expel the burned fuel and gas mixture. So this is now the layout of your four-stroke engine, just like the engine that you are actually using in your cars. Okay. This process causes mechanical work to be done on the vehicle's drive shaft and onto the wheels, thus causing the car to move. The exhaust gas that is pushed out by the piston is heat, okay, that has not been converted into use for mechanical work. It comes out the vehicle's muffler. So this is now your what? Exhaust manifold or your what? The air that comes out in your muffler or tambucho. Okay. Electricity. There are several ways of generating electrical energy, but the principle they follow is just the same energy transformation. Again, according to the law of thermodynamics, that energy cannot be created nor destroyed, but it can be transformed from one form to another. So therefore, this energy can be transformed. So we have a lot of sources of energy, even in our country. But then again, we are not maximizing it. Okay, again, energy cannot be created nor destroyed, but it can be transformed from one form to another. Okay, renewable energy comes from sources that are naturally replaced over a short period of time. Okay, renewable. So when you say renewable, these are energy that can be replaced in a short period of time. How about the non-renewable resources or energy? On the other hand, the non-renewable energy can only be replaced over a long period of time, just like your coal, just like your oil, just like your um and so on. So those are just few. non-renewable resources. Okay? Coal, natural gas, and nuclear energy power plants are non-renewable sources of energy. Hydroelectric energy, wind energy, and biomass power plants are renewable energy sources because they can actually replace over a short period of time. Except for nuclear energy, the Philippines make use of all these renewable and non-renewable energy sources. We are actually using it. But then again, talking about nuclear power plant, sure. Why the Philippines didn't actually push through the nuclear power plant in Bataan? The main reason is these are what? These are highly toxic, radioactive. Okay? It's okay to use nuclear power plant, but the problem there is how can we dispose the nuclear waste? Okay? This nuclear waste is what? Is radioactive. When you say radioactive, it can actually change your DNA structure. Okay? It can actually kill. Okay? This is the reason why the nuclear power plant is also used for nuclear bombing because again this is highly radioactive and it can cause serious damage if in case. Okay, this is the main reason that the Philippines consider the health of the people living near Bataan nuclear power plant. Okay, it is good that we invested on them. The problem there is how can we, okay, how can we um how can we get off, okay, of the negative effect, okay, the waste materials that these nuclear power plant or that this nuclear power plant is actually creating. Okay, remember that we don't have waste management for the nuclear waste. That's the problem. That's the main issue actually. Okay, it is actually ready for use, but the problem there is we don't have the facility to um get off, okay, to manage the wastes that these nuclear power plant will be producing. Okay, let's move forward with hydroelectric power plants or hydroelectric power. Okay, hydroelectric power plant or power is a renewable source of energy. Okay, since it is hydro means water. The primary component of a hydroelectric power plant are the dam intake, turbine, generator, transformer, power lines, and the outflow. Okay, a dam is usually built in a river collecting water in the reservoir. Okay, the water height. The water's height of elevation is important because the higher the elevation, the greater is the stored energy. Remember that this is driven by gravity. Okay, the higher it is, the bigger its energy, okay, from potential to kinetic energy. During the intake process, gates in the dam are opened, letting water enters in a narrow pipeline called the penstock. Since penstock is narrow, the water builds up pressure, causing the blades of the turbine to rotate. Okay, the turbines actually there is actually put there in order to create electricity. Okay, the turbine generates electricity. The turbine is connected to a shaft, to the generator, to the shaft. As the turbine rotates, the magnets are within the coils of the wire in the generator also rotate. Okay, this process produces current, thereby converting mechanical energy into electrical energy. Okay, again, we have now the conversion of energy from mechanical to electrical. Okay, from potential to kinetic. Okay, from mechanical to electrical energy. Okay, the product here is electricity. The electrical current is converted by a transformer into high voltage current before it is transmitted in a long distance through power lines. Okay, why do we need to convert this current to high voltage? Simply because it will travel in a long lines. Okay. From these long lines, a transformer is actually located on their posts, and this transformer will lower the voltage into 220 volts. Okay, that's our current. That is the current used by the Philippines, 220 volts. In Japan, it's 110. In common type of hydroelectric power plant, the water moves to the river downstream during the outflow process. So this is now the layout. As you can see, water is actually from the head pond going to the intake, a narrow pipeline, okay, of the penstock going to the turbine, okay, and the generator is in the above the turbine, okay, and of course the electricity generated by the generator will go to the transformer with a higher, okay, with a higher voltage going to the transmission lines. From the transmission lines, it will go to the houses, but it will pass through to what? To the posts, to the post near their houses to convert or to lower the high voltage transmission to 220. And then there you go. We did generate electricity through the current of water. Do you have any question with hydroelectric power plants or hydroelectric energy?
None, sir.
None, sir.
Okay. A pump storage plant is another type of hydroelectric power plant. Okay, it has two reservoirs, the high reservoir and the low reservoir. Water from the high reservoir is used to generate electricity, and used water goes to the low reservoir in which turbine is installed. So let's take a look at the layout later. Instead of allowing water to go downstream, the pump turbine pumps water back into high reservoir, making water available again for electricity generation. So instead of letting the water go back to the streamline, okay, mainstream line, okay, or the downstream, it actually pumps back to the higher reservoir in order for it to be available again for water generation or electricity generation. Let's take a look at later. Okay. So instead of letting this, okay, letting this water goes to the downstream, okay, or the lower reservoir, it actually pumps back again here in the head pond or the higher reservoir in order to what? To be available again for generation, electrical generation, okay, and so on. So in this case, we are actually letting water go to the downstream. So we are now actually dependent on the higher reservoir or the head pond. Once this area here becomes lowered, we cannot generate electricity here. But if we will pump again water back here, it will actually begins its cycle. So meaning to say that it is more convenient if in case we will actually return the water back. Wind power. Talking about wind power, we do also use wind as a source of energy, as a source of electricity to be specific. Wind power plant has these main components. You have the rotor blades, tower, shaft, and the generator, which generates electricity. The rotor blades are mounted on a tower that can be as high as 30 meters or more. At this height, wind moves faster and is less turbulent. Okay, when wind blows, the rotor blades rotate. So let's take a look at this. These blades are connected to a generator through a shaft, and the generator converts blades mechanical energy into electrical energy. Okay, there is again the conversion of energy from mechanical to electrical by these blades and the generator itself. The wind turbine has an anemometer. The anemometer is an instrument that measures wind speed. Okay, because again, talking about wind speed, it can actually destroy also the turbine or the wind turbine. A controller starts up the machine when the wind speed is about 13 kilometers per hour to 26 kilometers per hour, and shut off at the wind speed of about 89 kilometers per hour because it can actually destroy the equipment. Okay? This shutting off is necessary to prevent damage to the machine at a very high wind speeds. During emergencies, the brake stops the rotor either mechanically, electrically, or hydraulically if it has hydraulics. Okay? The rotor is directly connected to a low speed shaft, which is also connected to the gearbox to the high speed shaft. Okay? The gearbox increases the rotational speed to the required rotation speed, which is about 1,000 to 1,800 rotation per minute. That's RPM, to make generator produce electricity. Okay, this is now the component. As you can see, it has a what? Blade. This is the blade. This is the rotor. Okay. The generator, the controller, which actually what? Check on the wind speed. Okay. Once the wind speed is stronger to about 89 kilometers per hour, the controller will stop the what? The rotor in, taking in. The brake is in here. Okay. This is the tower. Okay. The generator, the gearbox, the low speed shaft. Okay. And so on. So this is the main component. Okay. That's the second, again, renewable sources of energy. How about biomass? What's with the biomass? Biomass comes from organic materials which contain stored energy in the form of chemical energy. Okay. These materials include plant and animal wastes, which release energy when it burns or decomposes. Okay. Remains of dead plant and trees, such as branches, bark, and wood chips and sawdust from the lumber mills, are the sources or are sources of biomass. So again, we are now maximizing the 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 natural, okay, the natural or the biomass or the natural remains or organic materials. These are organic materials. The stored energy from these materials can be converted into other forms, of course, because again, energy can be transformed from one form to another. So meaning to say that we can convert this one into useful energy. Biomass materials are fed into furnace, where these materials are burned. Okay, the heat produced in the process turns water into steam, and steam makes the turbine rotates and convert mechanical energy into electrical energy. Again, we maximizes the biomass by burning it, okay, to create steam, and this steam actually makes the turbine rotate and convert mechanical energy into electrical energy. Okay. Electrical energy transmission and distribution. After electrical energy is produced by power plants, it is transmitted over a long distance to be distributed in different industries and homes. Okay. The transformer is a device that transfers electrical energy from and among circuits with changes in voltage. It actually the one responsible in changing the voltage of these currents. Okay. Remember that voltage pushes electrons around the circuit. Okay. Generators produce electricity at high voltage or voltages of about 2,000 or 25,000 volts. Okay. A transformer steps up this voltage even higher, up to 400, okay, 1,000 volts. This stepping up of voltage is necessary to transmit electrical efficiency or electricity efficiently, or to prevent power loss. This is the one that I'm telling you a while ago, that this energy or this electrical energy should be what? Step up, or should be at high voltage. Otherwise, once they transmit, okay, this electricity, it will have a power loss if in case, because of these long cables. So as you can see, From the electricity generation, transmission, and distribution, you can see that the power plant generates electricity. Transformers step up because it will travel for along what cables and wires. Okay, transmission lines carry electricity long distance for long distances. Okay, once it will reach nearby post. Okay, your nearby post has its own transformer to step down the voltage into 220, and the electricity will travel in your houses at 220 volts. Okay. Do you have any questions so far? Do you have any questions so far? The discussed topic?
None, sir.
We had just discussed the renewable sources of energy, the non-renewable sources of energy, just like your power plant. Okay. Under renewable resources or sources of energy, we have hydroelectric power plants. What else? Steam engines. What else? What else? Geothermal power plants. What else?
Biomass.
Biomass. So these are just few, actually, these are the basics of these sources of energy. Okay. Again, questions before we go?
None, sir.
All right. So I think that will be all for today, class. Expect for a series of activities after this, my next meeting. And by the way, again, going back to your project for this school year, it is actually what? Again, a learning resource. A learning resource is anything that actually explains the concept. Okay, here are the concept. Okay, we have electric power plants, okay, geothermal power plant, wind power plant. Okay, what else? Four-stroke engine, heat engine. So these are just few of these concepts. Okay, I will just create a page for your project in your LMS. Right? I will give you ample time to do that. Okay, don't worry, since this is actually your output for this school year. Right? Questions so far
Yes, sir.
about your project?
None, sir.
At the over for today, class. Thank you for your participation. Let me record your attendance. Robbie, EM, AJ, Hillary, and Julian. Have a nice day, grade 9. Take care. Bye-bye.
Bye,
Bye,
Chair.
sir.